Lesson 3.2, Solving Quadratic Functions by Graphing. Objectives are to solve quadratic equations by graphing, estimate solutions of quadratic equations by graphing, and use quadratic equations to solve application problems. Here is our first warm-up. Does that function have a maximum or minimum value? Well, we look at our A, and since the A is positive, the graph is opening up, so it has a minimum value. We're using that same function, but we want to know the y-intercept. Y-intercept is when x is 0, which would be the C is the y-intercept. There isn't a C, so C is 0. You could also calculate, and the y-intercept is 0. X is a symmetry, same function. We use our equation, x equals the opposite of b over 2a. Opposite of b is -6. Double our a, we get 6. X is -1. We're still using that same function, and we want the x-coordinate of the vertex. It is the same calculation as finding the axis of symmetry. So once again, it's -1. Here's our graph. Now the information we already found, because it's the same function, our axis of symmetry is x equals -1, and our y-intercept is 0, and we also know it opens up. So the appropriate graph for that is B. Solutions to a quadratic equation. The solutions to a quadratic equation are the points at which the function intersects the x-axis. Solutions are also referred to as roots, zeros, or x-intercepts. There are 3 different things that could happen. There could be one real 0, and it's actually a double 0. That would have multiplicity 2. We'll get to that later. There could be 2 real zeros. That's when it crosses the x-axis in 2 places, or there's no real zeros, which would be imaginary zeros, and that is when the function doesn't cross the x-axis at all. Here's an example. We are to solve x squared plus 6x plus 8 equals 0 by graphing. It is already graphed there for you. What is the equation asking us to look for on the graph? Well, we're looking for the x-intercepts, or the zeros. And it crosses the x-axis in 2 different places, and that is at -2 and -4. Let's solve this equation by graphing. So x squared plus 2x minus 3 is going to be the graph of A. So the zeros are going to be x equals -3 and x equals 1. We are going to solve x squared minus 4x equals -4 by graphing. So we need to get it in the form where it's equal to 0. So we're going to have to move that -4 over. And the function we are actually graphing is x squared minus 4x plus 4. And I have the graph there for you. What are the x-intercepts? It's at 2, 0. There, it only touches in 1 point. So the solution to that equation would be 2. Solve this by graphing. So we need to graph that function. We'll need to put it in the form where it's equal to 0. We can put it in our graphing calculator if we want. It is going to open up. That eliminates D and B. And we need to figure out what our solutions are, and x is equal to +3. Number theory. Use a quadratic equation to find 2 numbers with a sum of 7 and a product of 12. So let x be one of the numbers. And if the sum is 7, then the other one must be 7 minus x. If their product is 12, we multiply them together to get 12. Of course, we need a quadratic equation. So let's distribute. and rearrange it and move the 12 to the other side. Since the x squared was negative, I made all the signs change so that it started off with a positive x squared. Graph the related function. There it is. Put it in my graphing calculator. It does cross the x-axis in 2 places, and that is at 3 and 4. So those are the 2 numbers that add to 7 and multiply to be 12. Let's do another one. They add to negative 10 this time, but they multiply to be 16. So let x be one of them. And the other one must be negative 10 minus x, because their sum is negative 10. Let's use the same plan and multiply those together to get 16. Distribute, get it all on one side, and we're going to graph. Put in my graphing calculator. It does cross the x-axis in 2 places, and that's at negative 8 and negative 2. So negative 8 and negative 2 add to negative 10, and they multiply to be 16. Here's another one. Use a quadratic equation to find 2 numbers with a sum of 7 and a product of 14. So once again, let x be one of the numbers. The other one must be 7 minus x. Multiply them together again, distribute, get it all on one side. But if we graph that, it does not cross the x-axis. So there's no x-intercept, so there's no such numbers that exist. Estimating solutions. Often exact roots cannot be found by graphing. You can estimate the solutions by stating the integers between which the roots are located. You can see this in a table of values if you put it in your graphing calculator. And you can see f of x, which is the y, changes signs between negative 2 and negative 1 for the x values. So somewhere in between negative 2 and negative 1, it must have hit 0. Same thing when the x values are 0 and 1, the y values change signs. So somewhere in the middle, it must have been 0. And in the middle, I'm just saying it's in between those two. It's not exactly in the middle. Let's estimate the roots for this. We're going to solve negative x squared plus 4x minus 1 is 0. I have it graphed there for you. The exact roots cannot be found with this graph. State the consecutive integers between which the roots are located. So here is one, and it's between 0 and 1. It crosses the x-axis between 3 and 4 as well. So one of the solutions is between 0 and 1, and the other's between 3 and 4. Here's another one, and I have it graphed there for you. X squared minus 4x plus 2 equals 0. You have a grid to make the graph yourself. Once again, it does not cross at a nice number, but somewhere in between 0 and 1, and it crosses again over here between 3 and 4. So A is our solution. Estimating roots using Desmos. This makes it so easy. So go to Desmos and put that function in. Just put in x squared plus 5x minus 7. And we're going to graph and see where the 0 is. So I put it in Desmos. And what's really nice is you can just move it around to get a window. If you click on where those zeros are, it tells you what those zeros are. TI 83 or 84 graphing calculator, you have to use the left bound, right bound thing. Desmos makes it so easy. So the 2 zeros are about negative 6.14 and about 1.14. We can use Desmos again to do this problem. Royal Gorge Bridge, the highest bridge in the United States, is a Royal Gorge Bridge in Colorado. The deck is 1,053 feet above the river. Suppose a marble is dropped over the railing from a height of 3 feet above the bridge deck. How long will it take the marble to reach the surface of the water or have a height of 0? We're assuming there's no air resistance, so we can use that formula right there. We saw it yesterday. T is the time in seconds. H sub 0 is the initial height. So we do need to figure out what the initial height is because that's not there for us. But the deck is 1,053 feet above the river, and we're doing 3 feet above that. So we need to put into our function 1,056 for our initial height. If you put that in Desmos and graph it, there is an option where you can change the window. Instead of just stretching and shrinking, it's an option up in the upper right hand corner. So it's easy to see. Once again, you just click on where it crosses the x-axis, and our solution is it takes about 8.12 seconds to reach the surface of the water. Let's do it again from the Hoover Dam. One of the largest dams in the United States is the Hoover Dam on the Colorado River, which was built during the Great Depression. The dam is 726.4 feet tall. Suppose a marble is dropped over the railing from, sorry about the typo, a height of 6 feet. So a tall person is dropping this above the top of the dam. How long will it take for the marble to reach the surface of the water? We have our same general formula, but we have to find the initial height. So the deck or the top again is 726.4, and we are 6 feet above that, so we have to add those together. We can put it in our function, use Desmos to graph it, and it will take the marble about 6.77 seconds to reach the surface of the water. Write a quadratic equation from given zeros. These are Alex examples. Given a quadratic function that has zeros 3 and 7, write the quadratic function. So we need to write them as factors. So a 0 at 3 has a factor of x minus 3, and a 0 at 7 has a factor of x minus 7. Because if you put the 3 in for x, that's 0, and 0 times anything is 0. Same kind of thing with the 7. We need to FOIL and simplify, and there's your quadratic function. Same kind of thing with this one. It has a negative, no big deal. We need to do x minus the 0, which is going to give us x plus 6, and then x minus 8, FOIL, simplify, and there's your function. Your assignment is in Alex. There are 12 questions, and it's a 10-point minor grade.